Good afternoon, and thank you everyone for joining today's webinar, Disaster Recovery or Disaster Prevention with OnRamp and SHI. My name is Deborah Danziger, and I'm the VP of Marketing for OnRamp. We hope that the information you hear today will help you with your disaster recovery or disaster prevention planning. Our goal is to keep the webinar to as close to 30 minutes as possible. To keep the flow going, we will answer any questions at the end, so please do feel free to submit your questions via the chat window throughout the webinar, and we will answer all that we can during our Q&A session. One quick note to mention, we've had a change to our speaker lineup this afternoon, and I'm pleased to announce that OnRamp founder Chad Kissinger will be speaking on behalf of OnRamp today. In this webinar, we will cover the following: introductions to our speakers, Chad Kissinger and Kurt Bosch, introduction to OnRamp and our services, definitions related to disaster recovery and disaster prevention, when to choose prevention over recovery, and we'll have a formal question and answer session at the end. Again, please feel free to submit your questions via the chat window, and we will answer all that we can at the end of the presentation. And as a thank you for attending today's webinar and remaining online until the end, you will be entered into a drawing for a $100 Visa gift card. And now please allow me to introduce our speakers. Chad Kissinger founded OnRamp in 1994. Since founding OnRamp, Chad has driven the growth and business model evolution of the company from a startup ISP to an established provider of data center services. Chad has been instrumental in shaping OnRamp's compliance-related services and is a thought leader on the subject, speaking at organizations around the country about meeting the stringent IT-related requirements associated with HIPAA, PCI, FISMA, FERPA, and SOX. As a principal architect with SHI's professional services organization, Kurt Bosch is responsible for architectural design and implementation for data center infrastructure solutions. Backed by nearly 20 years of IT experience, his responsibilities include organization, identification and creation of SHI intellectual property, architectural design and delivery for the professional services organization, and consulting with customers on the consolidation, process streamlining, and overall infrastructure design strategy. I would now like to turn the presentation over to Chad Kissinger, who will talk more in depth about OnRamp.
Thank you, Deborah. Appreciate the introduction. OnRamp is a data center operations firm. We specialize in providing data center services to companies that require high availability and high security. We do that by operating enterprise class data centers in the United States, where we provide, we deploy what we call a hybrid computing solution for customers to satisfy their computing infrastructure needs. Hybrid computing we define as a mixture of our customers' co-located equipment that they bring in to our data centers, often legacy equipment that is existing in another data center or in their offices, private clouds or managed infrastructure that we provide that's dedicated to the use of the one specific customer, our customer, and then for the lack of a better term, cloud-delivered services or shared services that we deliver from inside the data center that complement the co-located equipment that our customers brought in and the private cloud equipment that we've brought in. And we think that this hybrid computing really provides a powerful and flexible model for our customers to move forward with their data center mission. It allows them to opportunistically take advantage of managed infrastructure that we provide. Oftentimes, it facilitates them being able to, especially through the cloud services, take advantage of services that are delivered from very expensive equipment that they may not be able to deploy themselves, and do this all inside the same facility and connect all these resources together at Ethernet speeds without telephone companies involved. So very flexible model of computing in all of our facilities. We operate facilities around the United States. We'll talk about that in a little bit. But in each of our facilities, we deploy what we call full 7-layer support. It's unfortunate it's 7 layers because it's not the OSI stack 7 layers. We think of the data center a little bit differently than most people. It used to be 6 layers, and then virtualization came out and got it all confusing for us and added that 7th layer. But this illustration kind of demonstrates how we think of the data center operating, and off to the right a little bit about how our traditional competitors compare to us. Traditionally, we end up competing with companies that are either providing data center services or they're providing managed hosting services, but rarely do they provide both of them in this hybrid type of solution that I'm talking about today. We operate obviously at layer 1 and layer 2 in this diagram, the data center layer and the network layer. That's the physical facility where most data centers operate. But we also operate at the device layer. We're an HP and Dell partner amongst EMC and Cisco and SolidFire partner amongst a bunch of other partnerships. Whenever we deploy infrastructure inside our facilities for customers as a private cloud, we use what we consider to be enterprise class solutions. So think SANs, enterprise class SAN storage, enterprise class blade servers, those types of solutions. We never use off-brand or other type of equipment. And then through the next 3 layers, we also deploy enterprise class solutions. We believe the next 3 layers are software layers, the virtualization operating system and application layer. We're a VMware, Citrix, and Microsoft and a Red Hat partner, so we support the dominant versions of virtualization and the dominant operating systems in the marketplace. And then at the layer that we call the 7th layer, or the intelligence layer and monitoring layers, where we help watch our customers' hybrid infrastructures and really apply intelligence to them. And what we mean by intelligence is that, unlike our competitors, we don't just provide products and solutions to our customers for them to use in their computing infrastructure. We try to identify our customer's data center mission and make sure that we're appropriately addressing that. So when we have disaster recovery customers like we're talking about today in today's webinar, instead of just providing co-location or private cloud for them to use as a disaster recovery site, we actually help them think about what are appropriate recovery point objectives, what are appropriate recovery time objectives, how do you accomplish replication that can achieve those objectives, and how do you script the failover of operations during an emergency and the failback of operations after the emergency. When we have customers that need high security, like for HIPAA compliance or PCI compliance, we're not just giving them a secure infrastructure, but we're helping them worry about what does the security rule of HIPAA, for instance, require them to do to reasonably and appropriately protect their data. So we're going beyond just providing products. We're making sure that they're appropriately applied to the data center, our customer's data center mission. We operate data centers in Austin, Texas, and Raleigh, North Carolina, which we think are particularly well suited for disaster recovery. Many people don't know this, but Austin is in Texas, obviously they know that, but Texas has its own power grid. There are 3 power grids in the United States generally. One is on the eastern half of the United States, one is on the western half of the United States, and one is in Texas. And when there's large trouble on those power grids, it can often cascade across those power grids and cause trouble. Austin and our Texas data centers are somewhat isolated from that by being where they are. Austin, we're happen to be geographically far enough away from the coast, as is Raleigh, to avoid hurricanes. Austin's southern enough that we avoid ice storms, and we're in a very geographically stable place. So a very good location for disaster recovery. And then finally, we, OnRamp, one of the things that we specialize again in is providing high security and high availability hosting for customers that especially need those. So we concentrate on helping customers maintain PCI and HIPAA compliance. We're an SSAE 16 SOC 1 Type 2 company. We're operating as a SOC 2 company currently, and we're about to enter into our first SOC 2 audit period. We also are a U.S. EU Safe Harbor self-certified company, which means that we have agreed to adhere to European standards on data privacy and can therefore help our customers handle European data in a way that makes that's acceptable to them. So with that, I'll turn it back to Deborah.
Chad, thank you for the introduction to OnRamp's data center solutions. And Kurt, we'll turn the presentation over to you now to talk about our topic today, disaster recovery versus disaster prevention.
Thanks, Chad. Thanks, Deborah. So a couple definitions just to get them out of the way so we all know what, or at least what we agree we're going to talk about. The first one is business continuity planning. And I wanted to bring that up briefly just to sort of make it clear to everybody that's not what we're talking about, because business continuity planning typically refers to the ongoing operations of a business in the event or to provide effective prevention and recovery for an organization in the event of a disaster. And that would be the whole business. But we're not here to talk about business continuity planning. We're here to talk more specifically about disaster recovery and disaster prevention. Now, the disaster recovery we're talking about is the typical IT systems, putting in policies and procedures to enable the recovery of or continuation of vital technology. So that just means that you want to have a second site with the appropriate IT systems and enough replication, as Chad had already discussed, to allow recovery of those mission-critical systems that are necessary. Disaster prevention, which is a term that I've come up with on my own, is really about implementing a solution that prevents the disaster from affecting the business in the first place. So where disaster recovery is about what do you do when the IT systems go down, disaster prevention is about what do I do to make sure that doesn't happen in the first place. So, quick diagram just to show you the difference. Disaster recovery is about having a primary and a secondary site and duplicate systems, which means lots of extra infrastructure, lots of concern over getting the right latency, the right replication solution, lots of data moving back and forth for duplicating the data, lots of extra systems to manage, where disaster prevention is about setting up the appropriate number of links between the company and a colo site. And the colo site would be one appropriate to preventing disasters the company might actually see in whatever location it happens to be in. So why two ISP links? Well, redundancy, in case one goes down. So those are the real big differences between the two. In disaster prevention, we want to have the primary site protected to the point where we don't ever have to worry about what happens in a disaster. That doesn't mean the company shouldn't still pursue business continuity planning. They certainly need to. The business may undergo a disaster that they have to continue operating under, but at least the data is safe in that case. So when to choose one over the other? I'm certainly not going to tell anyone here on the webinar that one should, disaster prevention is going to solve all your current disaster recovery problems or is going to save you lots and lots of money. If it's the wrong solution, it's the wrong solution. So there are particular cases when one makes more sense than the other. Recovery should be chosen when. There are certain laws that require a company, particularly publicly traded ones, needs to have a disaster recovery solution in place. They've got to duplicate the systems. That's just the law. Or perhaps when a small subset of mission-critical systems, say for example an ERP system, which is only composes only a small part of the overall infrastructure, needs to be protected or recovered in the event of a disaster. The other systems, while useful, aren't necessary to ongoing operations. Prevention should be chosen when the local company can protect against IT disasters by actually choosing the right colo. And that is protecting against things like hurricanes, floods, fires, power outages, the random truck accident, things like that. There are too many critical systems that would have to be recovered. That is, all of the systems in place at the company site need to be recovered, and therefore the cost would be so high to do disaster recovery that really for the company it makes more sense to pursue disaster prevention. Do it right the first time. Don't duplicate the effort. And the last reason for choosing prevention would be potential defined disasters are almost completely mitigated by relocation. What that means is if you can only protect against the least probable disasters, but not the most probable one, prevention is probably not the right choice. That is, you need to find a colo that prevents against those most likely disasters that will occur. In the case of a company located in Florida, obviously that's going to be a hurricane. In companies located in Silicon Valley, that might be an earthquake. And if a solution can't be provided for a colo that prevents against that type of disaster, definitely not going to be the right choice. So the first step is obviously to identify the potential disasters. If we're going to go down the path of deciding if prevention makes more sense, we need to understand what we're going to prevent against. The four obvious ones, and the most well-known, are certainly earthquake, floods, tornadoes, and hurricanes. They're also well documented. Any Google search will turn up a FEMA map where these are most likely to occur. Simply mark your location on the map and figure out which ones are most likely. And then once you've identified the most likely natural disasters, we need to understand what the most likely man-made disasters are. They're a little less obvious, but they happen. You know, the building burns down, the power goes out. Any one of those two is a fairly major disaster. There are also such things as administrators who do occasionally make mistakes, and data gets lost or destroyed. And while moving this to a colo isn't going to fix that third one, it's certainly one that needs to be considered, and steps need to be taken and put in place to prevent that kind of disaster from occurring. So the point in disaster prevention is to move to the appropriate Tier 3 data center that can potentially mitigate these types of disasters. So in the case of a company that's located in Silicon Valley, perhaps San Francisco, the best choice would be one right across the bay in Sacramento, in a place that's protected against earthquakes. If you're in a part of California that's subject to disasters such as wildfires, the appropriate choice is a data center not too far away that doesn't have that problem. We want to find the appropriate Tier 3 data center that mitigates, again, against those most likely disasters. So how to implement? There's obviously a bunch of steps. I mean, this is really a fairly major project undertaking for any company or any IT organization. First, identify all the potential disasters. Second, determine a colo data center that mitigates the most likely ones. We've talked about that already. Lease and prepare the site. This one's pretty obvious, but it certainly has to get taken care of. Once you've identified the data center, you've got to figure out how much space you need and what that cost is going to be and budget appropriately. Order and schedule any leased lines from the company that have to be in place. We already mentioned that 2 ISP links between the company headquarters or the users who be using the systems and the colo have to be in place just for redundancy's sake, in case one link goes down. They typically take quite a while to get put in place. Trenches have to be dug, contracts have to be signed, legal has to go through them. Best to start that before you actually start moving any systems. Determine the best method to move to the new site. There are lots of ways to do this. One is what's commonly referred to in the industry as a forklift move. You come in with a forklift, put everything on a pallet, and move it from one site to the other. Some companies prefer to go through a complete technical refresh. Buy all brand new, put them in the new site, move the data. Decommission the old stuff. And then there are combinations of swing hardware and combinations of both a move and a tech refresh as needed. Just the hardware, just the storage hardware, maybe just the network. It depends. That's certainly something the company itself needs to determine and figure out the least costly, most appropriate approach. Orders any needed any hardware or software. This could be licenses for virtual infrastructure as well as brand new storage arrays. Assemble a team. This could be the internal IT staff that is available to do this, assuming the customer has the bandwidth, and or any consultants that can help them complete the effort in the least amount of time. We don't want to sit and move on this for 6 months. You want this done fast. There's no point in having the IT systems at risk, and there's no point in taking 6 months to get this done. Things could break in between. Plan the move of the IT systems and downtime for physical relocation, and then begin the project. So let's go back and talk about how we identify the potential disasters. We mentioned that they need to be identified. We didn't talk about actually how you might do that. Here we show you a possible matrix of what the potential disasters are for a particular company, in this case, Sacramento, California. And all we're doing is calculating a metric based on things like the percentage probability, a risk level, the length of a potential outage, and the severity, if one can be identified for that outage. Multiply all those together and come up with a number. Those with the highest number are the ones you need to protect against. In this particular case, you can see right away that we don't need to worry about hurricanes or typhoons in Sacramento, California. At the same time, tornadoes aren't very high on that scale either if you take a look at any FEMA map. The last one, building fire, is a best guess on my part, obviously. Only the company itself would know how likely a building fire is based on the age of the building, the state of the current fire suppression systems, and other factors as well, wildfires in the area, and so on. So, again, these are just a sample matrix. Clearly, you can develop your own, but this might give you a jump start. Next step would be to determine the co-location facility. You want one that's nearby, but not too near. Otherwise, it's going to be subject to the same disasters that the company might encounter in its current location. The reason for having it nearby but not too close is to keep the latency down. Anything too far away means slow access to the systems, which doesn't do the company much good in the first place. You want one with the lowest cost, obviously, but addresses all of the most likely disasters. So it should be located in an area with, low power costs. Space shouldn't be too expensive, and again, it should be in a place where potential disasters are low. Lease the space and then lease the lines. Preparing for the move is a little more involved. Think of it as an analysis phase or an assessment of what the best approach is for the particular company undertaking the move. Determine the method with the lowest risk and the least cost. Risk refers to how risky is it to move the systems in place to the new site. Typically, there's a lot of risk associated with that, but it's low cost. Or you could simply do a technical refresh and simply copy all the data over. Low risk, the data sits in two sites until you're ready to bring it up at the second, but it's high cost. You have to refresh the entire environment. Some combination of those two might be appropriate. That's where the analysis with the customer and the identification of the risk and the cost come in. Determine the resources, availability, skill sets, and availability for the project. Here we need to understand, the company needs to understand, can it actually do the work on its own? Does it have the staff, the bandwidth, the resources, the skill set to go off and do this, or do they need some help? And then identify where those gaps are. Do they need help with a project manager or something as complete as a team that's going to take over the entire move for them? And that can vary based on the company size and skill set of the staff. And then finally, determine the purchases required to complete the move. We talked about that already, but this is things like server, storage, and networking, and software. When the company is actually ready to move to the facility, we want to identify the project team. That's the internal and potentially external resources. Plan the move. This is going to be probably the most critical part of the entire project. All the rest of it, by its nature, is fairly straightforward. This one is critical because it actually means the systems themselves will be moving, and how this is done and the steps involved need to be written down and documented very carefully. Determine the downtime windows. When can we actually take the applications down to actually affect the move, whether it's just the data or the entire system? Which ones are mission-critical systems that need to move first? And what the potential risks are during the course of whatever type of move the customer is undertaking. I spoke earlier briefly about the risk associated with a forklift move versus that associated with data migration, but there's costs involved. Is it too costly, and is the risk can more risk be assumed by the customer? And then finally, if there are risks, identify them and come up with a potential mitigation strategy. If data loss may occur, make sure you got backups. If you are worried about the loss of a particular piece of hardware during the move, either because it's dropped or broken or damaged in transit, make sure you have a spare. Document the project plan. Once you figure out how the move is going to occur, get it in writing. Make sure all the stakeholders and people involved agree that this is the best approach, and finally begin the project.
Thank you, Kurt. And as a follow-up, you talked about kind of a step-by-step plan to implement disaster prevention. It might seem like a daunting task to a lot of companies. How does SHI engage, and what services do you provide to that end?
Well, we can certainly work with a customer to understand what the risks are that they're faced with, what kind of disasters they may potentially have. Happy to help them understand, what may be the best approach between disaster recovery versus disaster prevention. This doesn't even have to take very long, maybe a couple days to at most a couple weeks, just in general to get the IT staff to understand which way they want to go, and then document it so it's pretty clear.
Great, thank you. Could you, Chad and Kurt, talk a little bit about how the two companies work together to help customers achieve disaster prevention?
Sure. So, as I was mentioning earlier, we obviously operate at what we call our seventh layer, the intelligence layer, where we're trying to help customers, like disaster recovery customers, not just purchase co-location or hybrid computing from us, but really apply it appropriately to either disaster prevention or disaster recovery, as it may be, or business continuity, whatever the customer is interested in. What we often find is we get a customer that is having this philosophical conundrum. They find themselves in that you kind of described. What's appropriate? How far do I need to go? What is reasonably and appropriate for protecting my data? What kind of expense? And how do you measure that expense? And how do you think about it? And that's where we really bring SHI and partners like SHI in to help our customers think about those things and how do they appropriately choose our products to be implemented. And then we operate inside our facilities, and we oftentimes when we're dealing with disaster recovery customers, they have a primary site that we're not involved in. They have infrastructures that we're not involved in. So SHI obviously is a perfect fit for us in that sense, that they come in and help our customer fully plan the complete solution, the part that doesn't involve OnRamp.
Great. We'd like to now open it up to questions and answers, and Chad and Kurt would be more than happy to answer any questions submitted via the chat window, and we will answer all that we can in the remaining time that we have. We have a couple of questions coming in, one from Mark. Can you go into more detail about what a runbook is?
Well, runbook is nothing more than how you bring up the system you're trying to recover. So in the case of a 3-tier application with a front-end, middleware, and database, obviously the database has to get brought up first. Bringing up the front end does no good at all, the web front end. So the runbook in this case would talk about or discuss how you actually run or bring up the system from beginning to end during the case of a disaster and the system has to get recovered.
Right. And sometimes it may be supplemented with instructions on how to fail back operations at the end afterwards.
Absolutely.
Which is often a step that we see people that are planning for disaster recovery or any type of continuity operation not plan for. They don't realize that.
That's a good point.
They're going to have to remember that they're going to fail back to the primary infrastructure. At least that's the plan usually. And there's a discontinuity there when that occurs, and you need to plan for that and how you're going to get the data and the operations back to the primary infrastructure without an interruption.
Yeah. Once you're at the secondary site, you got to figure out a way to come back.
Right.
Most customers don't think that all the way through.
Right.
And then they're over there, and it's like, okay, now what?
Right. How do I replicate backwards, I guess, is the best way to say that.
Yep.
So we have another question coming in from Craig. I don't know if I need disaster recovery or disaster prevention. I know you talked a little bit about this, but can you go into some more detail?
Well, really it's about what risks the company or the customer themselves are willing to undertake, and what costs they can absorb. I mean, to a large degree, disaster recovery is a very expensive insurance plan. Insurance against the potential disaster you're trying to recover from. Disaster prevention says maybe we can reduce the cost of a full disaster recovery solution by doing it right the first time and making sure that disasters don't stop us from running. And really, at the end of the day, what you're trying to do is determine which one is more suitable.
That's right. If we've seen with the advent of technology and advance of technology, especially virtualization, it really has created a real spectrum of solutions for recovery. So it used to be that we'd have people that would back, we've been in business 20 years, so 10 years, 15 years ago, before virtualization, people would primarily either be just a primary set of servers with some backup tapes off-site, which a lot of people still do and is still an appropriate solution, or they would be a fully replicated site. They have two sites that are up, and they'd have some mechanism by which they would direct the users to the new site, and they would replicate the data in the back end to the secondary site. And that's typically very expensive to do. And then as we've seen virtualization and other technologies advance, shared storage and things like that, we're starting to see people do disaster prevention. Also with the advent of fast bandwidth, really high speed, low latency bandwidth, that's facilitated this idea that, hey, maybe I don't have my primary IT operations, even though all the users of it are in my office. Maybe I don't have that data center in my office. It should be remote because it can be made more reliable. Well, high-speed transmission has facilitated that. Virtualization has facilitated being able to quickly take snapshots of systems and replicate them in other places. It also facilitates using infrastructure that is primarily used for development and testing, or for secondary systems, maybe accounting systems, or systems that are not necessarily primary. That use that infrastructure in a case of an emergency, where you can just spin down the virtual machines of the kind of secondary systems, the dev test systems, and then use that freed up infrastructure as capacity for the primary or important compute loads that you're trying to protect. So virtualization and high-speed bandwidth has facilitated a lot of that, and makes it a lot easier for these companies to do more granular disaster recovery, disaster prevention. And I think it's interesting. Real quickly. We see a lot of companies doing a blended approach. There's not a total answer usually for an enterprise. We encourage enterprises to look at it on a system-by-system basis. So your time system, maybe that you're keeping track of your employees' vacation, if it's not a cloud service delivered yet, should be probably, is not as important to recover quickly as is maybe your billing system or the system that your customers use. So those would require different levels of different recovery point objectives and different recovery time objectives, and would facilitate saving money by maybe not spending as much effort on those secondary systems. Were you going to say something first?
Yeah, I just wanted to add that based on your point about virtualization, you're absolutely correct. It has simplified a lot of the replication, recovery mechanisms, approaches that people take, reduced the effort involved, and quite frankly, a lot of the cost. Such that even now, or today, disaster recovery can almost be affordable. And I'm not trying to argue against disaster recovery. I think it makes a lot of sense for a lot of customers. I'm simply pointing out that there are cases where maybe disaster prevention makes more sense. And because you now have clouds available to you, like Amazon, Azure, and a few others, including your own, it's quite possible and very easy for a customer to take their workload and move it into somebody else's cloud in the case of a disaster. Well, maybe not as easy as we'd like, but it's getting there. And that's certainly an option that they should pursue.
Right.
Well, thank you both. And that concludes our Q&A for today. And as a thank you to our attendees for attending today's webinar and remaining online until the end, you will be entered into a drawing for a $100 Visa gift card, and we will notify our winner via email. Again, we'd like to thank everyone for attending today's webinar. Thank you to Chad Kissinger and Kurt Fosh from SHI. As a follow-up to this webinar, you will be receiving an email with a link to the recording. And this officially concludes OnRamp's DR webinar series for 2014. Each of our 4 webinars are available for download at onr.com. And again, on behalf of OnRamp and SHI, thank you for attending.